Welcome to Mathematics for Engineers. Today's topic is an introduction to matrices. We'll start with their definitions. We can define matrices as numbers that are arranged in rows and columns. For this reason, we can also say that matrices are two-dimensional numbers. So the dimension is rows times by columns. Matrices are designated using a capital boldface letters. So for instance, matrix M can be written as M1 M2 rather, M3 M3 M3. Yeah. So this matrix M is composed of 3 rows and 3 columns. Right. Okay. Now, as we've said that the dimension of a matrix is its rows multiplied by its columns. So in this case, we have 3 rows and 3 columns. So we say that the matrix M is a 3 by 3 matrix. Now, let's look into the type of most common matrices that we have. Type of matrices. First one we need to look at is row matrix. So a row matrix, as the name indicates, is made up of only a single row. So therefore, if we can take, for example, matrix R can contain R11, R12, R13, and etc. So in this case, we see that matrix R is only made up of 1 row and many columns. So in this case, we can write matrix R has 1 by an n dimension. N could be the number of columns that matrix R can have. So let's, for the sake of discussion here, let's have matrix R as having only 3 columns. So we can then write matrix R is a 1 by 1, 2, 3. 1 by 3 matrix. So the dimension of row matrix R is 1 by 3. So another type of matrix we'll be interested in is the column matrix. Okay. So the same way, column matrix will have only 1 column. So let's have a matrix C11, C21, C21. So our column matrix C has a single column, and as you see, it has 3 rows. So Now appreciate that we always designate row on the first entry of the dimension and column on the second entry. So therefore we have 1 for the first entry, increasing columns 1, 2, 3. So in case of column matrix C, the column designator is still 1, but the row has increased from 1 to 2 to 3. So indicating that we have 3 rows but a single column. In the same way, the dimension of a column matrix is n by 1, but in this case we have 3 rows, we can write 3 by 1. Another type of matrix that we want to see is the square matrix. A square matrix will have equal number of columns to its rows. Square matrix can have a dimension of 2 by 2, 3 by 3, 4 by 4, and so on. Let's take an example of our square matrix S, a dimension of 3 by 3. So we can write that would be S11, S12, S13, S21, S22, S23, S31, S32, S33. So therefore the dimension of this square matrix is 3 by 3. Always the first entry of the subscripts stands for row and the second stands for column. Okay, so as such, any given elements in the square matrix or in any matrix is telling us that where that element is. So in this case, for example, this element is on the third row and second column. So if you count 1, 2, 3, and also in the column if you count 1, 2, you will definitely get that element in that matrix. So square matrix have equal rows and equal number of rows to its column, and the dimension is always n by n. It could be 2 by 2, 3 by 3, any number of rows by columns where the two are equal. Now I want to introduce the diagonal matrix. So the diagonal matrix is a special type of square matrix where its diagonal elements are different from 0, but all the non-diagonal elements are 0. Now assume any matrix D has got elements and it has to be a square matrix. Let's say D11, D12, D13, D21, D22, D23, D31, D32, and D33. Okay. Now the diagonal elements are defined on the diagonal that runs from top left to bottom right. So we call these elements diagonal elements, and the other diagonal, which is obviously this, that runs from the bottom left to top right, an anti-diagonal. So we call this diagonal, and this one anti-diagonal. Let's assume that we have a matrix G containing D11, 0, 0, 0, D22, 0, 0, 0, D3, 3. So this diagonal is a 3 by 3 diagonal. Its diagonal elements, those elements, alright, are all different from 0, and its non-diagonal elements, which are this, okay, are all 0. So in this case we have diagonal matrix. For a different dimension can be, for example, E can have E11 0 0 E22. This is a 2 by 2 diagonal matrix, and for diagonal matrix all elements ij where I equals j, eij must be different from 0. Okay. So when we have I equals j, that element will be different from 0. In G case, for example, we have D11, I and J are equal, different from 0, 2 2 different from 0, 3 3 different from 0. So all those are different from 0. So the others will be 0. Let's look at another type of matrix called an identity matrix. Now, an identity matrix is yet another form of diagonal matrix where the diagonal elements are different from 0, and they are also set to 1, and the rest non-diagonal elements are set to 0. So an identity matrix of dimension n, okay, so we have an n, its diagonal elements they are set to 1. Okay, so in this case, what does this in mean? So if I have an I2, this means this is a 2 by 2 identity matrix. It will be 1 0 0 1. So as you can see, the diagonal elements are 1 and the non-diagonal elements are 0. In the same way, I3 will be 1 0 0 0 1 0, and 0 0 1. Okay, so we have a 3 by 3 identity matrix. For all elements of any identity matrix, that element ij where I equals j, e ij will be set to 1. Okay, and all the rest will be 0. Now let's look at some manipulation of matrices, and so we'll be looking at matrix arithmetic. Okay, so some matrix arithmetics. This is adding, subtracting, multiplying matrices. Okay. So let's look at addition and subtraction. So matrix addition or subtraction is possible when both matrices have similar dimension. So when they have similar dimensions, it's possible to add matrices. For example, so let's take matrix A is a 2 by 2 matrix. So we'll have A11, A12, A21, A22. Okay. And matrix B will have, matrix B must have similar dimensions, so we can be able to add the two matrices together. We'll have B11, B12, B21, B22. Okay, so if we introduce another matrix called C, which is the sum or difference of matrix A and B, so this must have the same dimension. Okay, so this will have a C11, C12, C21, C22. Alright, okay. Yeah. Now what is C11 then? So C11 is A11 plus or minus B11. C12 is A12 plus or minus B12, and C21 is A21 plus or minus B21, and C22 equals A22 plus or minus B22. Okay, so what does it mean? So the matrix C in place of C11, so in the first row and first column we'll have the result of this. So this will be taken by A11 plus or minus B11, and the second here column on the first row will be A12 plus B12, and this will be A21 plus or minus, yeah, okay, in all cases B21, A22 plus or minus B22. Matrix C is made up of the corresponding the elements in each of the matrices to be added or subtracted. In the case of C, for example, the C11 place has been taken. Okay, C11 place here has been taken by A11 plus B11. Okay, plus or minus. Now, addition has some properties. So, properties of matrix addition. Yeah. Matrix addition is commutative. So it's commutative, which means A matrix A plus matrix B is equivalent to adding matrix B to matrix A. Okay. And the other property, so these common properties that we would use time and again are associativity. Associativity. So this is matrix A plus matrix B plus matrix C is equal to A plus into the sum of B and C.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment and subscribe, and don't forget to click the notification bell.